In this video, I'll be helping you with a math topic called Simplifying Exponential Expressions, as seen here in the OpenStax College Algebra 2nd edition text. Here we are using the rules of exponents that have been introduced in each of these examples. Starting with A, I can use the rules in any sequence. Typically, I like to start inside the parentheses and removing negative exponents. So I can rewrite inside the parentheses, making that n a positive exponent by moving it to the denominator as just an n1. And I still have the 3 exponent outside. So next I would apply this 3 exponent to each of the values inside the parentheses. I would have a 6 to the 3rd power, an m to the 2 power times the 3 power, so m to the 6th, and then in the denominator, applying the 3 exponent with the 1 exponent, they would multiply to give me an n to the 3rd. And lastly, I could simplify the 6 to the 3rd to be 216, so 216 m6 over n to the 3rd is our simplified expression. For B, I'm going to again start by moving my negative exponents into the denominator. So 17 to the 5th stays in the numerator. 17 to the 4th is positive when I move it to the denominator. And the 17 to the 3rd power again has a positive exponent when I move it to the denominator. From here, I'll leave the numerator, and in the denominator, since I'm multiplying with the same base, I can keep that base and add the exponents, 4 plus 3 being 7. And now my expression has the same base in the numerator and the denominator. So when I divide, I can keep that base and have the power of the top minus the power of the bottom. So 5 minus 7 is a negative 2. Writing this with positive exponents, this would be 1 over 17 squared. Moving now to example C, I can see that inside the parentheses, I have a couple of negative exponents. I can move each of those, so bringing the v negative 1 to the top as a positive 1, moving the u negative 1 from the top to the bottom as a u1. The other v would stay in the numerator, and I can continue to simplify. In the top, v1 times v1 is v2. And now that I've simplified inside the parentheses, the exponent outside applies to each one of the values inside. So our v2 will be v2 times 2, which is 4. And u1 will be u to the 1 times 2, which is 2. This would be our simplest form. For example, D, we can again start by rewriting some of these negative exponents, here by moving them into the denominator. So in the first part, our negative 2a to the 3rd will stay in the numerator, and the b1 moves to the denominator. In the second part, our 5 and b squared stay in the numerator as the a2 moves to the denominator. And from here we can multiply. Our negative 2 times 5 would be a negative 10. In the numerator we have an a3 and a b2. In the denominator we have a b1 and an a2. So there are some parts here that we can combine. The a3 divided by a2 would be a to the power of the top 3 minus the 2 from the bottom, so just an a1. And then the b squared and the b1, we would also keep the base b and have the power of the top 2 minus the power of the bottom 1. 2 minus 1 is again 1. So our simplest form being negative 10ab. For E, we could do this in a couple of different orders. But the one that I think makes the most sense here is, since they have the same base being raised to these exponents, we can keep that base, x squared square root of 2. And then since they're being multiplied, I can add the exponent. 4 plus negative 4 giving me a 0 means that I have this value in the parentheses raised to the 0 power will always give me 1. And then our last example, for f in the numerator, I have this 5 power on the outside. That applies to everything inside. So the 3 would be raised to the 5th power, and the w to the power of 2 times 5, or 10. In the denominator, the 2 applies to everything. So the 6 would be squared, and the w negative 2, I would multiply the power inside and the power outside to be negative 4. From here, the numbers 3 to the 5th can simplify as 243, and the 6 squared simplifies as 36. The w's can be combined as the power of the top minus the power of the bottom, so 10 minus a negative 4, or 14, this being our simplest form.